All right, we had one little piece left to finish up in section 10.2, and that piece of information was about circle graphs or pie charts. There's a couple of different names for them. And we'll flip to the back and take a look at that slide and talk about how to use the protractors that I just handed out to be able to construct those. All right, so this consists of circular region partitioned into disjoint segments. This graph shows how parts are related to a whole. I feel like this is the third time we've talked about a part-to-part, part-to-whole kind of thing, and this shows a really good part-to-whole kind of relationship, whereas bar charts show really good comparison relationships part-to-part. There are a few pieces of information before you even need your protractor. So just from a very concrete standpoint, drawing a circle. I'm not bringing compasses for you to do that. You're welcome to grab a neighbor's water bottle and draw a circle. You're welcome to sketch a circle for the moment. It's not a big deal. If I do a question like this from a test, I usually have the circle already on there for you because I'm not interested in how perfect can your circle be. That's not my goal, okay? So a few things then. We're going to take a look back at the grouped frequency table from example 5 to construct our circle graph. So if you want to flip back in your notes over there. What we're going to be doing first is just a little bit of arithmetic to figure out the quantities we need, and then we'll talk about how to use the protractor to draw it into the circle graph itself. Sound good? Okay, so let me go back to it, to our grouped frequency. Okay, so these are the values that I'm needing to know right now. I'm really needing the 3, 2, 4, and 9. Those are the important features, okay? So if you want to just jot those numbers down, 3, 2, 4, and 9 for the A, B, C, and D. So we have A's were the 9, right? B's were the 4. I'm writing them as numerators of fraction because that's what I'm going to need to do with them in a minute. And then C's were 2, and the D's were 3. 3 or 4? 3. So I think it was like that. All right, so what we need to know is we need to know what percentage of the whole this is. If this is a diagram that's supposed to compare a part to the whole, we need to compare the part that is the A or the B or whatever to the whole. So how do you suppose we get the whole in this situation? Add up those individual parts. So we have 9, 4, 2, and 3. How many tests did we have total? 18. So the denominator of each of these fractions is going to be 18. So the first thing I'd like for you to do, we've already done this before in different sections, is to actually find the percentage that this is. So what do we do that? Well, we take what we just did and we divide it, right? Each of the fractions is divided. And then we're going to multiply by 100 to turn it into a percentage. So 9 over 18 times 100% is what? That one's 50%, yeah. What is 4 over 18 times 100%? Whoops, didn't get that in the right. When we're looking at percents, we're looking for one decimal place, right? No more. What do we get for this one? Did you have it? 22%. 2 over 18 times 100. Well, if the previous one was 4 over 18, it was 22%. This must be 11%. Does that sound right? Okay. And then I need 3 over 18 times 100. What's that one going to give me? 16. We can do whole numbers is fine. Whole numbers are one decimal. I'm good with either one, but we don't need a whole slew of decimals. All right, so whole numbers is what somebody's already done so far. So what? 17%. Now, recognize that these should all add up to 100. I think they do on this particular one. You might be off because of rounding somewhere along the way, that they might add up to just a tiny bit more or a tiny bit less, but it should be approximately 100%. Okay, so these are the percentages. The other thing that I need is I need to know how much of the entire circle this is. Right, this is the percentage it is, and I'm going to represent this on my circle, so I needed those values. But I also need to know what percent of the circle it is. So how many degrees are in a circle? 360, right? So take a step back then. I'm going to give myself just a little bit more space and move this down. When I did the 9 over 18 times 100, if I had done the 9 over 18 times 360 degrees, I would have had 180 degrees. That's what that one is. For part B, 4 over 18 times 360 degrees. What is that in degrees? Grab a calculator if you don't have one out yet. That's because you're going to need them. So you have that one yet? It is 80. Thank you, Emily. 80 degrees. And then I need the 2 over 18 times 360. The reality is if the last one's 80% or 80 degrees, then this one must be 40 degrees because it's half, right? Yeah, because it was 4 over 18 and then, yeah. And then the last one, 3 over 18 times 360 degrees. What's that one? 160 degrees. Okay, everybody good with my values so far? All right, so in terms of drawing the picture, the degrees are the valuable pieces of information, okay? In terms of putting the details into the diagram itself, like what they represent and all that, we need all of it. Okay, so we're going to need the percentages and the degree markers. All right, so go ahead and either grab a neighbor's water bottle or if you have it on your own, or just sketch a circle yourself. And what we want to do is you're just going to estimate because we're trying to be not super precise where the center is. The 180 degrees is pretty easy to draw in a picture. We don't need to worry about the protractor so much. Why? It's just half of the circle. So you could actually draw a diameter through the middle of your circle, wherever it is you want it. So that we don't lose track as we go, what letter grade does that represent? Those are the A's. So you need to label it. These are the A's and what percentage it is, not the degree marker. That's not important visually. That's how I created it. What I need is that this is 50%. Okay, so the percentage goes in there, and the labeling of what the diagram, it is, goes in there. I don't necessarily care whether you go from right to left or left to right, but the A has to touch B, and then C, and then D. So while it's fine for me to put the angle that I'm going to do for B on the right-hand side or on the left-hand side, it wouldn't be okay for me to put the C's and the D's touching A and the B not. Does that make sense? There needs to be a reasonableness in how we're actually drawing it so that the A touches the B, touches the C, and so forth. I mean, in terms of the pieces of the pie. All right, so let's take our protractors now. What we know is that we need an angle of 80 degrees next. Okay, so I don't care where it is you line it up, but your protractor is actually going to look like it's upside down. Where are the extra protractors? There should be a couple extra at this point. At least, okay. Let me use that balloon. Is that one an extra? Can I switch you just so that you guys can see it from the audience? Sorry, thank you, Hannah, I appreciate it. Okay, so when you line up your protractor, it's going to be upside down here, okay? And the part that's in the center, that's the dot, so everybody see that, needs to be on the center of the circle. So your dot will line up like this with the horizontal piece along the diameter. Okay, and all of them are like that, even if you've got the little bitty ones. Does everybody see what I'm saying? If you're not, please ask right now. The dot that's in the center, it looks almost like it's magnified on your protractor itself on most of them. Should be on the center of the circle, and then the horizontal line that passes through it should be lined up on your diameter. All right? Now, if you'll notice, there are two sets of numbers going around the protractor. One set of numbers goes from small, 0, all the way up to 180 on the other side, and then there's another set going the opposite direction. That's just because you can go from either direction depending on how you're measuring your angle, okay? So if you want to put your angle B on the right-hand side, or if you want to put your angle B on the left-hand side underneath A, right? It doesn't matter. You're just going to still use your protractor with the corresponding values. So let's say, for instance, let's all draw it so that we're on the right-hand side, so we're all drawing the same thing. So if you're going to draw your picture so that it looks like that the angle B is right down here, approximately. I don't have a protractor to show you on here, so just bear with me. But what you're going to do is you're going to count from 0 all the way till you see the 80 on there. All right, starting with the lower value, 0, all the way till you get to 80. And then you're going to make a mark. So probably on your paper, depending on your protractor, the mark might not even be in the circle. It may be somewhere, out here. Right? And you're just going to connect the dots. So you're going to line up the center of the circle with your dot that you've made at that degree mark, and you're going to connect them. If it's outside of your circle, you don't go outside the circle, but you're going to connect till you get to the circle. And once you have that portion of it, this will be called B, and it will be 22%. That's what we had for the letter graded B. An angle measure of 80, but it was 22% of the circle. And it should be reasonable, right? It shouldn't look like that seems odd. This is a little bit less than a quarter of the circle. That's what 22% is. It's a little bit less than 1/4. Okay, here's where things get a little bit different. What you're doing next is you're going to use, again, the dot for the center. It's going to be the dot for your protractor, right? But you're going to turn your protractor so that your protractor has its straight, that horizontal line that's making, along the line that you just made for B. Okay, that's your new reference point. That's the new 0 angle. Because what we're going to do is we're going to measure from that line segment around this way for whatever the angle C is supposed to be. And it says angle C is supposed to be 40 degrees. So you're going to take your protractor and you're going to line it up and you're going to get something that, whoa, that wasn't it. Something that looks like, we're going to ballpark it on my eyes to look something like that. I don't have a protractor, but you do. Okay, and so you're going to measure it with the center along, or a center of your protractor at the center of the circle, the horizontal line along the line that's green on my screen, and you're going to go out 40 degrees from that. The cool thing is, if you measure that last angle, it should be whatever it said D was supposed to be. So mine says 60 degrees. Hopefully yours does as well. So again, if you turn your protractor again with your dot at the center and the new line that you just created right here as your horizontal line, this should measure out to 60 degrees-ish. And there's a level of accuracy here where we're not going to be perfect. I get that. But it should be reasonable. So this one should be the letter C. And that's 11%. D, and that's 17% for our circle. And then, of course, we need a what? We need a title. We need a title for our graph, our circle graph. And these are grades on a second exam. Any questions on that? It's all good? Okay. How many of those were supposed to be that I told you to skip? I mean, what is left in your note of your homework that's actually pertaining to circle graphs?
It's like all of C and then one on A and one on B.
Everything in section C? Okay.
Circle graph.
Okay. How many problems total? 6 problems. Okay. So here's what we'll do. Hang on to those. Bring them back next time. Oh, that's not nice. Don't say yes. That means that you were planning on that.
No, I wasn't planning on it.
You were just hoping for it. All right. Okay, so hang on to it. Hang on to it. I'm sure the grader will be okay with that. So hang on to that and bring it back with those pieces filled in for next time. Sound good? Okay, cool.